My name is Shad Gupta and I am a lecturer in Department of Computer Science, University Polytechnic, Tinthankar Mahavir University, Madhwar. And today my topic is inheritance in C++. Inheritance is one of the most important features of the OOPS, and OOPS is stand for Object Oriented Programming. Inheritance is the method or process by which object of one class can access the property of another class. Inheritance is the capability of one class to access properties and characteristics from another class. The class whose properties are inherited by other class is called parent class, and it is also known as base class or superclass, and the class which inherits properties of other class is called child class. It is also known as derived class or subclass. Now we can understand this concept by a real-time example because you know that OOPS concept is based on real-time problem. So we can understand this concept by a real-time example of vehicle. In this example, we consider a group of vehicles: bus, car and truck. So we need to create classes for bus, car and truck. The method fuel and brake will be same all of three classes. If we create these classes without inheritance, then we have to write all of these functions in each of the three classes as shown in the figure. We can see that the process results in duplication of same code 3 times. This increases the chance of error and data duplication. To avoid this type of situation, inheritance is used. If we create a class vehicle and write these two functions in it and inherit the rest of the classes from the vehicle class, then we can simply avoid the duplication of data and increase the reusability. See this diagram in which the three classes are inherited from vehicle class. So vehicle class is a base class and all three classes are subclasses: bus class, car class and truck class. Using inheritance, we have to write the function only one time in place of 3 times. As we have inherited all of the three classes from base class. So all the three classes can access all the properties and function from base class. So this is the concept of inheritance. Why we use inheritance? To increase the reusability of the code and to make further usable for another classes. We can use the concept of inheritance. When we inherit an existing class, all of its method and fields become available in the new class. Hence, code is reused. The advantages of inheritance: save time, reduce the chance of error, makes programs easier to write, it saves memory space, it increases reliability of the code. Now, the topic is base and derived classes. A class can be derived from more than one class, which means it can inherit data and function from multiple base class. The syntax of derived class is class derived class name colon access label base class name, that is a data members and methods. Access label specify the type of derivation, private by default or public. This is a class derivation figure, and in this figure we have two classes. One is point class and second one is 3D point class. Point class is a base class and 3D point class is a derived class. The code of base class is class name. There are two variables which are protected, and there is one function which is a public. This is the code of derived class. Class derived class name colon access specifier base class name. It also have one variable which is a private. A derived class can all access the property of base class. So it access the variable of base class and function of base class. Now we introduce another class. The class name is sphere. That is a derived class of 3D point. The code is class derived class name colon access specifier base class name, which also contain a variable which is a private. And this class contain all the properties of 3D class and point class, because it is a derived class of 3D class, and 3D point class is a derived class of point class. So 3D point class access all the property of point class, and sphere class contain all the properties of 3D point class. Point is the base class of 3D point, while 3D point is the base class of sphere. This is the accessing base class member. The accessing specifier are three types: private, protected and public specified. Which objects are allowed to access member of the base class? Private. This member is only accessible within the base class. Protected. This member is accessible within the base class and its derived classes. Public. This member is accessible within the base class, its derived class and outside classes. Now, this concept is understood by a chart. In this chart, this row is indicate the access specifier for member of base class, and this column is indicate the class which access the member of base class according to access specifier. When a member of base class is public, then it is accessible by same class, and a member of base class is protected is also accessible by same class, and a member of base class is private, it is also accessible by same class. When a member of base class is public, it is also accessible by its derived classes, and a member of base class is protected, it is also accessible by derived classes. But a member of base class is private, then it cannot be accessible by derived classes. When a member is public in base class, that it is also accessible by outside classes, but a member is protected or a private in base class, then it cannot be accessible by outside class. This is the inheritance visibility mode. In public mode, this is the most used inheritance mode. In this, the protected member of superclass becomes protected member of subclass and public becomes public. In protected mode, the public and protected member of superclass becomes protected member of subclass, and in private mode, the protected member and public member of superclass become private member of derived class. So, this concept is understood by a figure. This table showing all the visibility mode. In this table, this row is access specifier of base class variable, and this portion is mode of base class. In base class, there are three variables x, y, and z. Variable x is a public variable, variable y is a protected variable, and variable z is a private variable. And this base class in public mode, this base class in protected mode, and this base class in private mode. Now, when a base class in public mode, then public variable of base class behave like a public variable in derived class, and protected variable of base class behave like a protected variable in derived class. But private variable of base class cannot be accessed from derived class. In this code, we see that a public variable in base class also public in derived class, and a protected variable in base class also behave protected in derived class, and a variable in base class is private cannot be accessed from derived class. So this is a public variable in derived class, this is a protected variable in derived class, and z variable is not accessible from derived class. Now, when a base class in protected mode, then public variable of base class behave like a protected variable of derived class, and protected variable of base class also behave like a protected variable of derived class. But private variable of base class cannot be accessible from derived class. In this code, we see that a public variable in base class behave like a protected variable in derived class, and a protected variable in base class also behave like a protected in derived class. But a private variable in base class cannot be accessible from derived class. Now, when a base class in private mode, then public variable of base class behave like a private variable of derived class, and protected variable of base class also behave like a private variable of derived class. But private variable of base class cannot be accessible from derived class. In this code, we can see that a variable public in base class is behave like a private in derived class, and a protected variable in base class behave like a private in derived class, and a private variable in base class cannot be accessible from derived class. We have different types of inheritance: single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and hybrid inheritance. Now we discuss about single inheritance. In, in the single inheritance, there is only one base class and one derived class. In this type of inheritance, only one class can be derived from the base class. This is the simplest form of inheritance. Class A is a base class or superclass or parent class. Class B is a derived class or subclass or child class. This is the syntax of single inheritance. Class A is a base class and class B is a derived class which access the properties of class A. Multi-level inheritance. When a class is derived from a class which is also derived from another class, then it is called multi-level inheritance. In this figure, class C is a derived class of class B and class B also derived from class A. So, class A is a base class of class B and class B also a base class of class C. This is the syntax of multi-level inheritance. Class A is a base class and class B is a derived class from class A and class C is also a derived class from class B. So that is a multi-level inheritance. Multiple inheritance. Multiple inheritance is a type of inheritance in which a class derives from more than one classes. As shown in the diagram, class C is derived from class A and class B. So, class C is a subclass that has class A and class B as its parent class. That is the syntax of multiple inheritance. Class A is a base class, class B also a base class, and class C is derived class from class A and class B. Hierarchical inheritance. In hierarchical inheritance, more than one class inherit from a single base class, as shown in the figure. Class B, class C, and class D can access the property of class A. So, class B, class C, and class D is a subclass or derived class, and class A is a base class or parent class. This gives it a structure of hierarchy. This is the syntax of hierarchical inheritance. Class A is a base class, class B is a derived class, class C is also a derived class of class A, and class D also a derived class from class A. Now, hybrid inheritance. Hybrid inheritance is a combination of more than one type of inheritance. In this figure, we have two types of inheritance: multi-level and multiple. Class A, class B, and class D is a multi-level inheritance. Class B, class D, and class C is a multiple inheritance. This is the syntax of hybrid inheritance. Class A is a base class, class B is a derived class from class A, class C is also a base class, class D is a derived class from class B and class C. Thank you.